It's time for us to take a deeper dive into the concept of functions. We have already been using functions. We have already been exploring some of the concepts related to functions. But in this session, let's step back and let's just look at all the different pieces that come together for the function to work and to understand the implication of each of the stuff therein. If we have a look here, there is a basic structure for a function, and this defines the syntax. The function has a name. The function has an input list or a parameter list that is denoted by the parentheses. The function also has a return type. And so far, the return type that we have been using has been void, which indicates that this particular function is not going to generate or return an output. The function also has a body, and the body is defined by the opening brace and the closing brace. So for now, I'm just going to call these curlies. So the opening curly and the ending curly. And inside of that, we will have the set of instructions that defines the body of the function. Now, what's the purpose of a function? The purpose of a function is to carry out a task. We have already indicated that the symbols that we see here are actually operations. And once they are operations and they carry out a task, then it means that in essence, they are functions or they have been implemented in some shape or form as being a function. As developers, as programmers, we are able to create our own functions. And you would have seen that being demonstrated in our earlier sessions where we created the class and we associated the functions within the class. It's important to note at this point that we can have functions which we call standalone functions. And we call them standalone functions because they are not associated with a class. And that is one of the reasons why it's important for us to use the correct terminologies as we proceed through the course. So when we have functions that are associated with a class, we call those functions methods, so that it's easy to distinguish when we are talking about a function that is associated with a class, a method, or a function that is not associated with a class, which in this case would be a standalone function. Now, functions don't need to take in any inputs. And if it does not take in any inputs, then the parameter list is going to be left empty. We have already seen this being displayed when we look at methods like show. We have not yet looked at any functions that generate or return an output. And I'm using those two terms interchangeably for now. Now note for the declaration, it says that whenever we specify the return data type, the name of the function, and the parameters, if any, then that is how we declare the function. Whereas the definition are going to be the codes within the curlies. Let's now jump over to our demonstration portal so we can have a look at functions and what they bring to the table. So I'm going to create a standalone function, void, let's call it calculate. We have the parentheses, and we have the begin and we have the end. Inside of this void calculate, I'm going to create some integers. Let's call them num1 and num2. I'm going to put some values into num1. So num1 is 10, and let's put a value into num2. Num2 is 3. And let us then add those two values together And let's put that into another variable called answer, or let's call it result. So result is assigned num1 plus num2. And let us see out result at the end of all of that. So the result is, and then we're now going to make use of the result variable. So we have created a function called calculate, and we now need to make use of this function. Now remember, the only things that execute are the operations that we place within the main. By the way, please note that the main is a function. If you look at the structure of the main, there is a return type. In this case, it's an integer. There's the name of the function, which in this case is main. There is a parameter list, which takes in nothing. And we have the beginning and the ending curlies. So main is a function. It's a special function, however. And it's special in that this is where we place the statements that we want to execute. So it's special. So we can't have two mains in one program. So that's something to bear in mind. Now, if I want to make use of the calculate function, then it means that inside of main, I now need to call that function. And I call the function by stipulating its name. So it's called calculate. I have to also specify the parentheses because that is what defines the function inputs. In this case, there's no input. So I can just put a semicolon and then let's hit the run button so we see what's going to happen. And we are seeing here that it says that the result is 13. As it should be, because we have 10 and we have 3. We're adding those values together. We're putting the result in this variable called result. And then we are displaying the content of result. And just to make things clear, there is a difference between the prompt and the variable. So I don't have to have the word result inside of the prompt. Prompt is just what the user is going to see as the message. So I could, in fact, have it saying the answer is, and then I print the content of the variable, which is result in this case. So if we re-execute, then it now says the answer is, and we are still seeing the value 13. So this is an example of a standalone function. It's called a standalone function because it is not associated with a class. And this is perfectly fine. In fact, this is how programs were developed back in the past. We would have a set of standalone functions, and we would find a way to have them interact with each other by virtue of the inputs that we pass into them and the outputs that we obtain from them. This led to a whole lot of issues, though, in terms of properly structuring our codes, because the standalone functions are not grouped together in a cohesive manner. And that is why the industry has moved to object-oriented programming, where we are able to create our classes, and inside of our classes, we're only going to put those functions, those operations, which are pertinent to the class. So they make sense for the operation of the class. And because of this structure, we are now able to group things in a more cohesive or convenient manner. So we have just created our first standalone function. But this function is not particularly useful from the standpoint that the numbers, the inputs are fixed. And it is fixed based on the programmer determining what these inputs are. For this function to have some value, we need to be able to pass inputs into the function through the parameter list. So I'm going to modify this by getting rid of the inputs that we are using inside of the function. So notice I'm removing num1 and num2. And I just create some new parameters. I'm going to call the parameters param1 and param2. So int param1 and int param2. These just represent parameters. So it's two integer parameters or two integer input. Result, therefore, is going to be param1 plus param2. And everything else remains the same. Now, when we come to the main program, we need to call the function correctly. If the function has parameters, then we need to ensure that the parameters are being used whenever we call the function. So just let me put a note here. This is the function call. So this was a function call without parameters. And now we are going to make the function call with parameters. So I'm getting rid of the first calculate because there's no such thing anymore. And we now have a new calculate that takes in parameters. And the parameters in this case, let us say 5 and 6. So this is now a function call with parameters. So line 27 is no more inside of the code. It has been commented out. And let's now execute and see what's going to happen. So it says that I am missing a semicolon. So let's go to line 29 and fix that. There needs to be a semicolon at the end of the function call. And let's re-execute. Now it says that the answer is 11. So 5 and 6 gives us 11. So what is happening here? The placement of the parameters is important. And the placement of the data values is important. So the first data value is going to go into the first parameter. And the second data value is going to go into the second parameter. Therefore, 5 is parameter 1 and 6 is parameter 2. We're going to add those two values together on line 18. So 5 and 6 gives us 11. We put the value into this thing called result. And then on line 20, we are displaying the content of result. So the answer is indeed 11. But let's step this up a bit more. Based on this program, when we execute, we're always going to see 11. Once again, it is the programmer who determines what these values are. So we want to find a way to make it interactive, meaning we want the user to be able to enter those values and the necessary calculation is done, which means we have to make use of the concept that we learned in our previous lesson, where we are now able to deal with I/O, specifically taking in inputs. So what we can do within the main program, and let me get rid of line 27 just to ensure that everything is a bit cleaner. We're now going to define some variables. So int, let's now call it num1 and num2. These are going to be what the user is going to be placing their values into. And then we're now going to prompt the user. So we're going to tell the user to enter num1. So that's the first number that they're going to enter. Let's call it enter number 1. And I'm going to store number 1 inside the variable num1. And we're going to do something similar where we're asking them to enter number 2. So copy and paste. And we're going to put a new line before enter number 2. And the variable that is going to hold number 2 is going to be num2. So having done that, we can then say, instead of taking in 5, we take in num1. And instead of taking in 6, we take in num2. And what this means is that the value that the user has entered into num1 and num2 are now going to be passed into the calculate function. So if we execute again, All right, so I have something probably incorrect here. Let me just have a check. I'm not using the C in, so that's my bad. It should be C in num1 and C in num2. Remember, with the C in, we need to change the direction of the operator. All right, let's try that again. There we go. So enter num1. Let's say it is 10. Enter num2. Let's say that is 7. And we're seeing that the answer is 17. Now, this program is much better because we can re-execute as many times as we want. And now it is the user who determines what the inputs are. So for example, they can enter 4 and they can enter 9. And then the answer is 13. So we are seeing here that we have now structured the program a bit better by virtue of making use of the parameters. One final thing to add to this now is the return data type. So in this case, we are simply printing the value or the output that is generated from within the function. The challenge with that is if we now need to manipulate the result on the outside of the function or within the main program, we are not able to do so. So now there has to be a way, or it is important for us to find a way to send the output of the function back to the main program so it can be used within the main program. And I'll give you a quick example. I could want to add 2 numbers, and then having added those 2 numbers, I want to double it. This function that I have called calculate is only designed to add the 2 numbers. It's not designed to double it. So it means that in order to double it, I would need to have some way of getting access to the output in the main program so that I can then double it. And in order to do that, we can now make use of the return keyword. So just to quickly make the adjustments and reconfigure the main program so that you can see what is happening, I'm going to change the return data type from void to an int, meaning this function will generate an output that is integer in nature, and we will send that output outside of the function so it can be used, which means we're no longer going to be using a cout, because a cout means that we are doing a print within the function. That's not what we're trying to do now. What we're trying to do is to send the output to the outside of the function so that it can now be used. And we do that by using the return keyword followed by the variable that contains the value that we want to send outside. So right here, we have the calculate operation that takes in 2 inputs. It adds the 2 inputs, places the result or the output into this variable called result. And then we are going to send that result, that output, to the outside of the function so that it then becomes visible in the main program. Now, if it's visible in the main program, then usually what we want to do is to be able to assign it to something. So I'm going to create another variable. Let's call it output. Let's call it f output, meaning function output. And then we're going to say that f output is equal to whatever output is generated by the calculate function whenever we pass in the values num1 and num2 into it. And once we have that, then we can now display the function output. So we can say function output is, and then we say f output. And what is going to happen here is that, in essence, we'll get back the same thing, but the structure of how the program is written is going to be much better. And let me demonstrate quickly. So we were working with 4 and 9. I'm going to work back with the same values. So 4 and 9. And we can see that the function output is 13 as we expected. So the 9 and the 4 is 13. But what now obtains is that we are now able to manipulate this function output that has been generated by the function. So I can now double it, for example, by saying times 2. And now I can say function output doubled. So it's going to be 13 times 2. So let's try that. We're entering 4 again, enter 9. And now we are seeing that the function output double is now 26, because it would have been the 13 that the function would have sent out as its output. And we're now doubling that output by multiplying it by 2. So 13 times 2 gives us 26. So this is now a better structured program, because the function is now able to do what it needs to do. And when it calculates whatever outputs it needs to calculate, that output can then be sent back into the main program so that the main program can then do what it needs to do with the output. And I think that this has been enough in terms of talking about functions and how they operate. And what we will do as we continue to move through the course is just to use some demonstrations or some more demonstrations so that this can be clear as to how it can be used in a variety of situations. Please note that what I have done here today is to make use of standalone functions in terms of demonstrating how things work. But we can still take the same concept of a function and use it in the context of a class where we're now talking about methods, and the methods would operate in a similar fashion.